Alright, welcome everyone. In this video we're going to go over one problem from 13.4. Remember, that has something to do with arc length. So here is our problem that I've selected for us. This is from our fall 2016 exam. Notice we already did 5A. So we're going to do 5B, which says find the length of this curve where t ranges from 0 to 4. So again, we need to remember what is the arc length formula. Right, so that's going to be the integral from a to b of the magnitude of the derivative of r of t. So you can see I need to fill some stuff in. So first of all, maybe let's go ahead and take the derivative. So I'm going to find r prime of t here. And I'm going to do it component by component. So when I take the derivative of 9t, I get 9. In fact, let me switch notation too. I'm going to use kind of my standard vectored notation here. All right, the second one here. Ooh, this is a little bit more difficult. But I'm taking the derivative with respect to t. So actually, maybe before I even take the derivative here, let me rewrite this. This is 4. And let's see, we have 3t cubed, and that's all side of a square root. So that's raised to the 1/2 power. So okay, let's go ahead and take the derivative of this. So the 4 would be along for the ride. And then we would take the derivative of the outside. So the 1/2 would come down, leave the inside alone, and I'd reduce my power by 1. So that inside is 3t cubed. And then according to the chain rule, I would multiply by the derivative of the inside. So that's going to be 9t squared. Okay, finally, the third component. When I take the derivative of this, I get 6t. That's a lot easier. All right, let's take one line to maybe simplify that second component a little bit, right? So I have, let's see, there's this 4 and the 1/2. That's going to make 2. Let me go ahead and combine that with the 9t squared. So that's going to be 2 times 9 is 18t squared. And then I'm going to leave this as 3t cubed raised to the negative 1/2. Okay, and then 6t. All right, so there is the derivative. But remember, I need to integrate the magnitude of the derivative. So let's go ahead and take the magnitude of this derivative here. So I'm going to have the square root of 9 squared is 81 plus, all right, 18 squared. I'm just going to leave this as 18 squared for the time being. T squared squared is going to be t to the 4th power. And when I take this and I raise it to the 2nd power, right, I'm just going to have 3t cubed raised to the negative 1st power, right, because again, I squared it. And then comma, oops, sorry, not comma, plus, and when I square 6t, I get 36t squared. All right, looks like we can do a little bit of simplifying here. So let's see, I'm going to have 81 plus, I'm going to go ahead and write this as 18 times 18. You'll see why I'm doing this here in a second. T to the 4th is just t to the 4th, and when I have something raised to the negative 1st power, that's actually in the denominator, right? So let me go ahead and write this. And now it's very clear we can see that actually some of these t to the 4ths cancel out with a t cubed in the denominator, and so we're just left out with t plus 36t squared. Okay, and now I wrote this as 18 times 18 because you can actually see there's a little bit of cancellation here. The 3 and maybe one of these 18s can cancel out a little bit, and so I just have 6. Okay, the other thing that I can recognize is that actually all of these terms have a factor of 9 in them, right? So if I was to go ahead and factor out a 9 from all of these things, right, I have the square root of 9 times a bunch of things, and well, so let's see, we would have 9 plus, if you was to factor out a 9 from maybe this 18 right here, you'd have 2 left over, right? And so 2 times 6 would just be 12, that's nice. And there's still just 1 t here. Plus, if you were to factor out a 9 from here, you would have 4 left over, t squared. And the nice thing, of course, about this is that square roots, they distribute over multiplication. So I can take the square root of 9 times the square root of all this stuff. And of course, the square root of 9 is just 3. Okay, so that's quite a bit of simplification. You can argue, right, why are we doing all of this simplification? Well, we need to remember our next step is to integrate this thing, right? So I'm going to be integrating from a to b, in this case 0 to 4, of the magnitude of the derivative of our parameterization. So that's going to be my 3 root 9 plus 12t plus 4t squared dt. And if you stare at this for a little bit, right, in general, whenever you're trying to integrate things with square roots, these can be very difficult problems. I mean, that's from Calc 2 when we kind of started talking about trig integrals and all these sorts of things. There are only a handful of problems that really work out fairly nicely. And so in this case, actually, this thing inside of the square root ends up being a perfect square. And this is something that you probably saw a few times in your homework, but let's go ahead and see that again. So, okay, before I even get to that, let's factor out the 3 here. So I have the integral from 0 to 4, and now, this thing inside of the square root, the claim is this is equal to 3 plus 2t squared. Let's go ahead and double check this, maybe off to the side here. If I take 3 plus 2t, and I multiply that by 3 plus 2t, and I do the firsts, I would get 9. If I do the inners, I would get 6t. If I do the outers, I would also get 6t. And if I do the lasts, I would get 4t squared. And so I get 9 plus 12t plus 4t squared, exactly what I wanted here. So this ends up being a perfect square, and that's very nice, right? Because the square root of something squared is going to nicely cancel out. So these just cancel out, and we're left with 3 times the integral from 0 to 4 of 3 plus 2t. Okay, really quick, I have to say, for any of you mathematicians who are watching, technically these don't exactly cancel out, right? They give you the absolute value. But I'm just excluding that absolute value because the values of t that we're plugging in are from 0 to 4. So those are all positives, right? So the absolute value is not actually going to do anything in this case. So that's why I just wrote 3 plus 2t. Okay, now this is something that is much easier to integrate. So when I integrate this, I get 3t plus t squared. I'm going to integrate that from 0 to 4. So that's going to be 3 times, let's see, 12 plus 16. And you subtract away when you plug in 0, but that's just 0. So that's going to be 3 times 28, it looks like. So 3 times 28, which last time I checked was 84 altogether. So again, we were trying to figure out the length of this curve that we have up here. Find the length of this curve, and the claim is that it should be 84. All right, so again, that's a problem from 13.4. The main things here were to be careful, right, when you were taking the derivative and taking the magnitude and then looking for perfect squares. So those were the 2 key ideas here of trying to find the length of this curve. All right, thanks for watching, everyone. I'll see you next time.